another one of our inequalities where we want to figure out which portions are going to be above or below our x-axis, is kind of how we're thinking about it as far as the pictures go. And it kind of looks like the nice ones we gave you in factored form, except for the fact that we're trying to figure out where it's greater than 5. So unfortunately, I can't just use my factors here, because we need this thing to be set equal to 0 because we have x times x, which means we have a quadratic over here. So before I can do anything with a positivity table, I need to get this thing set equal to 0. So we're going to start by multiplying out the left-hand side to get a 2x squared plus 3x. But we also want to get it set equal to 0. So at the same time, I'm going to minus my 5 from both sides. If you want to do that in 2 separate steps, that is totally valid. I don't know why my 5 is randomly bigger than everything else, but there we go. So we need to get it set equal to 0 because then I can use my factoring to find my factors. Because when we're doing this, we don't really have an easy way to see what is or is not greater than 5 without doing a full-on guess and check, plotting the whole graph up, and drawing on it. Ew. But if we get it set equal to 0, then all we care about is the sign, whether it's positive or negative. So we need to get this into our factored form. So factor however you choose. Our a times c, if we're looking for our split the middle or our traditional factoring. We're going to have multiplies make negative 10, adds to make a positive 3. What pair of numbers multiplies to make negative 10, adds to make positive 3? 5 and negative 2. So we're going to factor that however we want. I'll do it up here with our factoring by grouping. Where I take my 2x squared minus a 2x plus a 5x minus 5. I'm going to do my groups like this. And when we get our factors, we should get 2x plus 5 and x minus 1. Again, I don't care how we factor, just that we factor. Is anyone lost on the factoring part on this one? Or get anything different? Just start getting that up so it's a little easier to see. So we need it to be equal to 0. And then we want it in factored form so that we can find our roots, zeros, solutions. Where are our roots or zeros or solutions for this? Negative 5 halves and a positive 1. Because if I set my 2x plus 5 equal to 0, we get negative 5 halves. If we set x minus 1 equal to 0, we get a positive 1. So now we're going to draw our positivity table, meaning I'm going to start with my number line, where I'm going to put my zeros on it, smallest to biggest. So my smallest is our negative 5 halves. And our bigger one was the positive 1. Then we're looking at our 2 factors that we have there. We've got our 2x plus 5. I'm going to need another color because my factor is going to get in the way. There we go. So we've got our 2x plus 5. And we have our x minus 1. And we want to know about our function. So we know that these guys are our zeros. These are our roots. So I want to know what's happening outside of those. So I want to know what's happening when we're smaller than negative 5 halves. I need to know what's happening between negative 5 halves and 1. And I need to know what's happening bigger than 1. Because these are the spots where it hits my x-axis. That's where it equals 0. So again, you can just think a number that meets those qualifications. You can get an actual number and substitute pieces in. All I care about is it positive or is it negative? So if we look at things that are smaller than negative 5 halves, so smaller than negative 2.5. A good one to think about, you could do negative 3. You could do -4, -10. Doesn't really matter. Any number that is smaller than -5/2. I'm going to pick -3 just to kind of think about. You don't have to write down what number you're thinking about. I'm just putting it up there so that we all can see where I am. So if we think about x being -3, will this chunk be positive or negative? Negative. Because 3 times -3 would be -6, plus 5 is still negative. So this piece is going to be negative. If I have x is -3, is this piece going to be positive or negative? Negative. Since both of our factors would be negative over here, our whole function is going to be what? Positive or negative? Positive, because a negative times a negative is positive. So this down here is talking about our whole function. That's the big guy. Then we're going to do that same thing for the center, same thing for the right. So in the center, we're looking for between our -5/2 and a +1. What's a number between -5/2 and +1? 0. You could use -1. You could use +1/2 if you're feeling real mean. Like, you can, totally fine. If I use my x as 0, is this piece going to be positive or is this piece going to be negative? Positive. 2 times 0 plus 5. So we get a positive value here. Is this piece going to be positive or negative? Negative. Because we would have 0 minus 1 would give us a -1. So this piece is going to be negative. If I have a positive value times a negative value, are we going to have a positive or a negative down here? Negative. Because these two pieces get multiplied together. Negative. One more chunk. So then something bigger than 1. 2, 3, 7, 428. Doesn't matter. 2 is probably the most common choice. But you can do whatever you want. We just need something bigger than 1 outside to see what's happening here. So if we have a value bigger than 1, is this piece going to be positive or negative? Positive. Is this piece going to be positive or negative? Positive. So again, all I care about is the sign. I want to know if it's positive or if it's negative. So if I have a positive factor times a positive factor, what's our function going to be? Positive. So now I know that this section's positive, this section's negative, this section's positive. So if we want to know when our function is greater than or equal to 0, do we care about the positives or do we care about the negatives? The positives. So this is going to be one of my sections that I care about, and it keeps going forever that way. And this is going to be one of the sections that I care about. Can we equal our barriers here? Are we going to include them? Yeah. Because it equals 0. So we are going to have our 2 sections, because I have 2 places where we were positive. So our first interval is going to be from -infinity up until we hit this wall here. We hit this barrier at -5/2. And since we can include our barrier, we're going to put our bracket on it. Same thing on the right-hand one. We've got our bracket, and it goes from 1 to infinity. Again, technically we join them with a U. I'm not petty about the U part. Petty about the brackets versus parentheses, but not about the U. I don't really care. Okay. What's up? Because we want to know when this is greater than 0, so we're thinking about when we have like a quadratic, when it's above my x-axis. So that's when my values are positive. So if I wanted to know when it was below 0, when it's less than 0, and my values are negative, we'd be looking at the little ones.
Is it coincidence that the signs alternate, or is that like good here?
It's not necessarily that they alternate, but each of our factors is really only going to change one time, as long as we have linear factors. So we shouldn't really get like minus, plus, plus, minus, minus, plus, plus, plus if we wind up with a really big table. It shouldn't change back and forth as long as we have our kind of barriers at the top in smallest to largest order, which is why I've always done smallest to largest just like a number line, because then it's not going to alternate on us back and forth. It's only going to switch one time. Okay, questions on the kind of quadratic version of these? Because it's not always going to stay super nice quadratic. Sometimes you're going to get things like this. These are the last kinds that we're going to see. But we're going to approach them 100% the same way. We need to know factors so that we can find zeros so that we can make a positivity table. So here we've got x squared, or not, no we don't. We have x minus 2 over x squared minus 3x minus 10. And we want to know when that fraction, when that rational expression is greater than or equal to 0. So what we're going to do when we have something like this is we're going to go, and then we're going to say, wait, I see a quadratic in here. Let's factor that bit. So let's take a look at this denominator, our x squared minus 3x minus 10, and see if we can factor this thing. So if we wanted to factor that, where we have our a times c minus 10, our b is a minus 3. Oh, we've recently had those two pieces. What? Where we're going to have our minus 5. There we go. And a positive 2. Since we have an a value of just 1, you don't have to do our full factoring, but you can write the whole thing out if you want to. But I can rewrite this with our numerator of x minus 2 and our denominator being with our x minus 5 and our x plus 2 greater than or equal to 0. Those are all the pieces I need. I don't have to do anything more with this fraction. We're going to look at each of these factors, and we're going to figure out their root. There we go. So what are our roots for each of these factors? So for our x minus 2, it'll be our positive 2, right? So if x at x minus 2 equal to 0, add 2 to both sides, we get positive 2. What if I did the same thing for x minus 5? X minus 5 equal to 0. 5. X plus 2 equal to 0? Negative 2. So we're going to have our positive 2, a 5, and a negative 2. Those are going to be the pieces we put on the number line. We're going to set them up from smallest to largest. So this is going to be a little bit busier. I'm going to go from smallest to largest, so I'm going to have my negative 2. And my next one's going to be a positive 2. And I'm going to have my 5. Those are my barriers. I know that's going to be where this hits my zeros. So we got to figure out what's happening on either side. We're going to need to know what's happening with all of the pieces in this fraction. So I need to know what our sign is going to be for my numerator piece, that x minus 2. And so I'm going to need a line for that piece. I need to know what's happening in that denominator, so I need to know what's happening with my x minus 5. And I need to know what's happening with that other piece in my denominator, the x plus 2. And if I combine all of those pieces together, it's going to tell me what's happening with my whole function. So this is going to tell me about my whole function when I multiply everybody together. So this is kind of like my total row. This is my total. There we go. Let's make it a little thicker. Not total. Now, to be fair, pronunciation is not always my strong suit. So we're going to fill this in. So we're going to think of a number smaller than negative 2, something between negative 2 and 2, something between 2 and 5, and something bigger than 5. And again, you can think about specific values, or you can think about, it's kind of like vibes. And you can either fill this in columns, like we have been, or you can fill it in rows. It does not matter how we fill in this table. But we need to make sure we fill in so that we can figure out what signs there are. So I tend to, just since we're doing things together, put a number that I'm thinking of up here, so because you guys can't see in my brain. So when I'm thinking of a number smaller than -2, I tend to just pick like the next one. So -3, you could do -4, you could do -10. It genuinely does not matter. But if my x is something like -3, is this factor going to be positive or negative? Negative, because we would have -3 minus 2. That'd be a -5. That is negative. All I care about is it positive or is it negative? So if I have something like -3 minus 5, positive or negative? Negative. If I have something like -3 plus 2, negative. So then if I have a negative divided by a negative times a negative, which those are all basically, multiplication when it comes to signs. Negative times a negative times a negative. We're going to wind up with a positive, or we're going to wind up with a negative? Negative. Moving on. Next kind of thing. We're thinking about between -2 and +2. Well, my favorite bestie is in that little spot. 0 is a fine one to think. I'm between -2 and +2. Totally works. So if I have 0 minus 2, is that going to be positive or negative? For this box. Negative. If I have 0 minus 5, is that going to be positive or negative? Negative. If I have 0 plus 2, is that going to be positive or negative? Positive. So then if we wind up with a negative times a negative times a positive, are we winding up positive or negative? Positive. So again, thinking between something like 2 and 5. You could do 3, you could do 4, you could do 2.5. If you're feeling froggy, you don't need to pick decimals. You really have to, or really want to. I'm just going to think 3. Again, you do not need to put these numbers up here. I'm just putting it up there so that if you're looking at this later, you see what's happening. So if I take my 3 into x minus 2, so we do 3 minus 2, is that positive or negative? Positive. This one switched. If I have 3 minus 5, is this positive or negative? Negative. If I have 3 plus 2, is it positive or negative? Positive. So we have a positive times a negative times a positive. Negative. One last section to go. So a number bigger than 5. You could pick 6, 7, 10, 500. Doesn't really matter. I'm just going to go 6. It's right next to it. Not super hard calculations. So if I do 6 minus 2, positive or negative? Positive. If we do 6 minus 5, and 6 plus 2? Positive. So positive times positive times positive? Positive. Okay, so we know our whole function is below the x-axis here and here, and it's above the x-axis here and here. What do we care about? Do we want to know when it's below, or do we want to know when it's above? Above, because we want to know it is greater than or equal to 0. So we're looking at this one, and we're looking at this one. And we know that that one continues on. So before I write my intervals, I have one last thing to look at. Because now that we have fraction in our denominator, can my denominator equal 0? No, we run into problems. Can my numerator equal 0 here? Yeah. So I can equal 0. So I'm going to have some time when I could have a bracket, but I cannot equal 0 on these guys. So does -2 count as my answer? Can I include -2?
No.
No, because that one's in my denominator. So this guy is not included in my answer. I have to put a parenthesis. Hello, screen. Can we make choices? Thank you. I have to put a parentheses, still not the pen I wanted. A parentheses on my -2, because I cannot equal -2, it would give me a 0 in my denominator. Can I include the +2? Yes, because that's one from my numerator. So from -2 to +2, but +2 is included. Can I include the 5?
Why is -2 in parentheses?
Because if I have an x of -2, my denominator is 0. Because the -2 came from here. And the 5 came from here. If either one of these is 0, we wind up undefined, not equal to 0. So either one of these, I can't actually include. So even though it has an equals to, I can't equal the 5. Because if it equals 5, I just am undefined. So with our interval for the 5, it's also going to get a parenthesis. And it goes all the way up to infinity. So these two pieces are my answer here. And it's the parentheses and bracket that get wonky on these. Because we can include on an equals to for the numerator, but we cannot include for the denominator. So if we just have a greater than, or just have a less than, easy peasy parentheses for everybody. If we have the equals to, we just got to make sure we're not getting undefined. Okay? So I know they look a lot scarier. They're very similar to the quadratic ones. Yes, dear? The ones in the denominator will always only get parentheses. Because we can't divide by 0 or we're undefined. You would be landing on an asymptote there. We're going to try another one of these. Something like this one. So we've got -3x over x squared minus 9. And we want to know when that's greater than 0. Yeah, got your best. I'm sorry. All right. So on this one, we're going to need to be really careful because of this -3 in the numerator. It plays games with signs. First thing I need to do, though, is to try and factor this thing. What do we notice about this fraction? Difference of squares. So what is my denominator in our factored form? X minus 3 and x plus 3. And it doesn't matter which order we have it in. Totally cool. So what are our roots for this one? What are the values we're going to use? Three and -3 and 0. In our numerator, -3x equal to 0, we get a root at x equals 0. So we can't forget about it just because it doesn't look like a factor. It's still a piece there. So this guy still gives us a factor at 0. So we have 3 factors here, 3 roots. We can't forget about that x in the numerator. Just thinking about how we get roots. So if we'd like x plus 3 equals 0, x minus 3 equals 0, we can do the same with this thing to find our roots. So I'm going to draw my positivity table. And I'm going to put these in numerical order. I always start with my smallest one. I want the pink. There we go. I'm going to have my -3. Then we're going to have our 0. Then we're going to have our +3. And we're going to put all of our factors over here. You can either put the -3 on its own. So like if you have a coefficient, you can put that on its own. Or you can keep it with its like little buddy. So this guy's with his little buddy here. I'm going to put the whole negative 3 here, especially when we have a coefficient that is negative. You need to have it in your positivity table because it's going to play games with all your signs. So our negative 3x is one of our factors. And they're going to have from our denominator our x plus 3. And from our denominator our x minus 3. And it genuinely does not matter which order we have these pieces in. If you want to put the x minus 3 in your plus 3, you can put the 3x on the bottom. Like, it genuinely does not matter what order these pieces are in the table. I do strongly recommend that you keep your, total at the bottom. It's going to make things easier. Don't try and squeeze that guy in the middle. So this is going to be for my whole function, and you can either label it with a star, you could put f of x, you could put the whole thing here, you can just put product, you can just leave it blank. I don't really care. But know that we're looking at that bottom row. That's what's telling us our total. So I'm going to draw my little walls because every place we have one of these walls is where it's hitting that x-axis. So I want to know what's happening around it. And again, you can fill this in columns, you can fill this in rows, genuinely does not matter. So if I think of a number smaller than negative 3, is this box going to be positive or negative? Positive. Because if I have a negative 3 times like a negative 4, that would give me like a positive 12, so it's going to be a positive. So if I have a number smaller than negative 3, is this going to be positive or negative? Negative. If I have a number smaller than negative 3, is this going to be positive or negative? Negative. So my product here, positive times a negative times a negative. Are we going to be positive or are we going to be negative? Positive. Because a positive times a negative gives us a positive. So this is an example of a time when I wasn't thinking of a specific number. I didn't plug it in. I was just kind of getting the vibe. You don't have to think a specific number, but you can if it helps. So we think about something between negative 3 and 0. Like negative 1 would be a good one to think. Is this box going to be positive or negative? Positive. Is this going to be positive or negative? Positive. So something like negative 1 plus 3 would give us a positive 2. All I care about is it positive? Is this one going to be positive or negative? Negative. So if we have a positive times a negative, are we positive or negative? Negative. All right, so now we're between 0 and 3. Positive or negative? Negative. If we're between 0 and 3, positive or negative? Positive. And between 0 and 3, are we positive or negative? Negative. So if we have a negative times a negative, positive. One last section. So now we're thinking bigger than 3. Negative on the top one. If we're bigger than 3, positive. Because something like 4 plus 3 would give me a positive 7. That works. Bigger than 3, positive or negative? Bless you. Positive. So our overall function is going to be negative. Do we care about when it's positive or do we care about when it's negative? Positive. Because we want to know when this is greater than 0. So I'm looking at my positives here and here. Can I include the 0? Is it okay to equal 0?
No.
Nope. So everybody gets parentheses. It doesn't matter who or where they're from. So we're going to go from negative infinity all the way up to our negative 3. But we close it with a parenthesis. And then I've got to skip over the -3 to 0 part because that one's below my x-axis. I don't want it. And my next section where we're above our x-axis is between 0 and 3. So these two pieces, again, technically they join with a u. I'm not going to be petty about the u. That's just our best answer. Are these two pieces here. Okay? We'll do one more. Yeah, I just wanted to make sure it was the one I wanted. This one.
I was just about to ask her if you can make me one that's negative.
Yeah, we're going to do one that's negative. This one also has another kind of funky piece for us with the x squared. We have in our numerator, we've got our x squared times x plus 2.
Do the x plus 2's cancel out?
And we have in our denominator an x plus 2 times x plus 1. All right, you know we've spotted at least one thing in here. The x plus 2's do cancel out. The only thing that they tell us is, since they're the exact same top and bottom, I just can't have this factor in my denominator. Hello. Thank you. This one. So these do cancel out. We just are going to need to be careful when we're looking at our answer, because what would the root be for that factor? -2. So we cannot have x equal to -2. Otherwise, everything else is the same. So this is the exact same as if we had x squared over x plus 1. We just got to kick -2 out of my answers. Can't equal it. I can equal anything else, just not that guy. So we're really looking at x squared over x plus 1. And we want to know when that is less than or equal to 0. So what are our roots that we're looking at here? -1. Oh, I heard it. It was very quiet, though. 0. Our numerator. Don't forget about x's. Even if they don't have anybody added onto them, it still causes a root. If it helps, like, you can always put these in the parentheses. It's totally fine. You just don't have to have them there. So we have roots at -1 and 0. So my number line, I'm going to set it up like this with my -1 and 0. That's a weird looking 0. There we go. And I'm going to take my two factors. I'm going to take my x squared, and I can treat my x squared just as an x squared, or you can put it as an x times x. Either way is fine. And we're going to include our x plus 1. And that'll give us our function. So thinking about our x squared, if I have a number smaller than -1, is this going to be positive or negative? Positive. In fact, is this ever going to be negative? X squared, always positive. So I know, no matter what's going on here, everything's going to be positive. I can do that. So if I have a number smaller than -1, is this one going to be positive or negative? Negative. If we have a number between -1 and 0, is this positive or negative? Think about if x is -1/2 plus 1, positive. It's little, but it's positive. What about things bigger than 0? Positive. So my function here, positive times a negative gives me a negative. Positive times a positive is a positive. And a positive times a positive is a positive. So if we want to know when this is less than or equal to 0, which section are we looking at? The negatives. We're looking at this guy over here. Can we equal the -1? No, because it's in my denominator. This would be 0, so not included. What else is not included? -2. So you can either write this as, like, think of it as its own little mini number line, where we have our -1 that we've got to skip over, and our -2 that we've got to skip over, that we're going to have this inequality and this guy. So we'll have it as 2 separate intervals. Right, I did. Boop, like that. So we're going to have our -infinity up to -2. And then we've got to take from -2 up to -1. We just have to jump over that -2 right there. So that guy that canceled out gives us an extra jump that we have to do. We have to kick out -2. Because if I go back to my original equation, my original inequality, if I had x equals -2, I would get something undefined. Okay? So, x squareds, be really careful because we're going to play games with signs. Yes, Jim?
So, as our roots that we were really looking for, was the 2s and not like, is the 1 and 0 irrelevant now?
Well, the -1's still our edge piece, like it's the barrier over here. Because it's not just from -2 to infinity. We have all these options between -1 and -2 that still give us a functional answer. So if I have -1.5, it's less than 0. This graph just looks funny. So if I was to try and plot this guy up, I know that starting at -1, so I'm going to say -1 right here. That's -1. So now we'll pick this one positive one. We're below here, but it comes down and it's kind of like this. So if we're looking for the parts where it's below the x-axis, we're just looking over here at this guy. This guy's just up here and bouncing because we had that x squared at 0.
Oh, 0.
Okay. So it's weird. You don't need to do any like sketches on this. Yeah. But they're weird. They're awkward. These tables are kind of funky and awkward to get used to, but that's what they are. Okay. So we can work with these. We're going to be done right there. And I am going to cut number 36 from the homework. Because we're not going to deal with it. We don't need to deal with it. Skip 36. The rest we can do. They're very much like the ones we did today or yesterday. So don't do 36 because it has, you could do it. It's rationals on either side. Set it equal to 0. You can. But, it's a lot. Okay. So make sure if you are missing any quizzes from Unit 1, you got to do those. I'm passing all the quizzes back on Thursday. If you wait until after I pass them back, you don't get to do it. Got to take the quizzes. So if you're missing anything, please, please, please let me know.